All right, so today I'm going to be going over an Air board that I have already fixed. I'm going to show you what was wrong with it, what my thought process is, and I'm going to explain a little bit of how some of the power circuitry works. So in this Air board, when I plugged it in, I had 0.5 volt on PP bus G3 hot. So I'm going to open up the schematic here so that I can show you where I find the list of voltage rails and how I have any idea what the hell I'm talking about or what I'm looking at. Because one of the first problems a lot of people have is they have let's say you have a multimeter and you know what it is, how to look for voltages and how to measure voltages, but you don't know what you're actually supposed to be measuring or where you're supposed to be measuring it. That's a big problem. And that's what this document here is for, that, you know, I have to go onto a Russian forum and give them lots of money in order to get, because, you know, there you actually get this shit from the manufacturer. There they actually tell you how to fix their own fucking products. No, that would make life easy. So I'm going to scroll here. Here we go. So this page is called Power Aliases. Now, as I've explained, everything on the Airs and the Retinas is more miserable than on the regular machines. And that's even down to the schematics, because on regular schematics for regular old A1278s and A1286s, you used to get this print. You used to get this whole list on page 1, 2, and 3. Now you get it on page 62. I mean, not at the end, not at the beginning, and on page 62. This is the first place you should look when you have any problem with a computer not turning on. The first place, page fucking 62. So yeah, Airs are just blah. So PP bus G3 hot over here, it says, is supposed to be 8.6 volts. I measure it and I get 0.5 volt. Now, one of the things I've talked about in many other videos here is about the one-wire circuit. So in order for this to turn green, in order for this to actually do any communicating with the computer's SMC and for the SMC to communicate with the charger so that the charger can turn itself on, you need the one-wire circuit to be working. And the one-wire circuit works off of the PP3V42 power rail. If you watch my one-wire circuit video, you'll understand how that is. I checked the PP3V42 circuit on here, and it's 0 volts. So one of the things that I did was I looked around the 3.42 volt power area, and I noticed that there was one resistor that didn't look the way that it should. So let me just bring that up here under the microscope. And unfortunately, I have already fixed it, so you're not going to get to see what the old resistor looked like, but well, what are you going to do? So right over here, this resistor had a bunch of brown on the other end. And this is a particularly important one. So I've talked before about what this ton pin does on the CPU vCore power rail. So if you search for a video called CPU IMVP_TON, you're going to see my talk on that. And that's an important pin for power supplies where you have different inputs. So let me just open up the schematic here so I can show you what that does. So let me explain how this works. Every power rail in the machine has a single input. So for example, the 5 volt power supply comes from the 12 volt power supply. The 3 volt power supply comes from the 12 volt power supply. The CPU vCore line comes from either the 5 or the 12 volt power supply. I forget. They all have inputs that are the same. So the switching power supply knows exactly how often to do the switching in order to get your desired output. This power supply here, the PP3V42_G3 hot power supply, this one has to turn on first. Remember, this is the one that's going to turn on the SMC and also other functions. This needs to come on before anything else. So if this needs to come on before PP bus G3 hot comes on, and let's say your battery is dead, so you don't have PP bus G3 hot, you need this to create it, this has to come directly from the 18 volts from the charger. Because again, this has to come first. The charger is going to create PP bus G3 hot, but in order to turn the charger on, you need PP3V42 to be present, which means you need to turn this on directly from the 18 volts over here. So if that's the case, you're going to be getting power in directly from the DC and rail. So over here, you can see this is the direct 18 volts. This is the direct 18 volts coming from the charge port. So over here, that's the charge port, and then it's coming through here, to this chip. So this chip is going to turn the 18.5 volts to 3.42 volts. Now, let's say that we don't have the charger plug. Let's say we don't have the charger plugged in. Let's say we have a full battery. Then this chip is going to be getting its power from PP bus G3 hot. Remember, in order for the computer to create PP bus G3 hot, which is the 8 volt rail for the entire machine, the charger has to be plugged in. However, if the battery is present, the machine itself is not going to be creating that rail. It's simply going to be running off of the 8 volts that's already there in the battery. So in that case, we're going to be getting power to create 3.42 volts from the battery. Now, this chip is going to have to switch at a different frequency if it's turning 18.5 volts to 3.42 volts. It's going to have to switch less often than if it's changing 8 volts into 3.42 volts. So how does this chip know how often it's supposed to be switching? What tells it? Well, there's the ton pad on the CPU V-Core chip, on that Max chip that I was talking about in the other video. And here, it's this SHDN over here. So right after this diode, there's going to be either 18 volts if we're powering from the charger, or 8 volts if we're powering from the battery. That's going to go to VIN. But also, it goes to this little pin over here. And if I search for this chip, I'm pretty sure we'll be able to find a PDF that tells us that this sets the switching frequency. Because again, we already have voltage input. Why would we need another input from the same place? Well, that is to set and that's this for this voltage divider here for setting the switching frequency. So R7080 is what was blown. So we're going to search, and this is one of the things I really encourage you to do, because keep in mind that the people who were doing this a long time before you, they didn't have Firefox, they couldn't hit Control-K and just look all this stuff up instantly. Now there's a good chance that we're not going to find a data sheet. Yeah, there's a good chance that all these data sheets will be bullshit. Hey, what do you know? It's not bullshit. Cool. Is this for the same chip? Okay, my chip is AED, this one is A. Close enough for rock and roll. So let's see. So we're trying to figure out what pin 8 does. I want to show you that that's what pin 8 does. Now here's the thing. When you look at documents like this, keep in mind that you are not an engineer. You are not designing this stuff. You are not, again, that's not the purpose of it. We're looking at this document with the intention of learning one simple thing, right? That's the only reason that we're looking at this. So this, I don't care about feedback voltage line regulation or switch VCE SAT. No. Get the. I care about pin out. That's what I care. What do these different pins do? That's the dummy section of the document. That's what we're looking for. So let's see if we can find the dummy section of the document. The dummy section of it is where they pretty much list the pins and they tell you what each one of the pins do. And most data sheets have that. So here we go. So we're looking for which SHDN. The SHDN pin is used to put this in shutdown mode. Okay, so I'm totally and completely wrong. It does not do that at all. I thought it did something, and that's not what it did. I am completely and utterly wrong. I thought that that was what this is for, and that's not what that's for at all. So the SHDN pin is used to put this into shutdown mode. Tie that to ground to shut down this. Apply 2 volts or more for normal operation. Okay, so that doesn't set switching frequency. Again, I'm open to the idea that I don't know everything. And again, that's one of the reasons that I'm always suggesting that you Google and you use your brain and try to figure things out. And that's why I'm very, very happy that I'm able to Google and learn and find data sheets. Because, again, a lot of people, they have this idea that all of this information that I know, I was just kind of born with it. And I'm just, I'm just an asshole when I don't decide to give it away. It's really, that's not the case. It's over here. Again, and there was a time where to figure this out, you'd have to call the manufacturer, you'd have to deal with a bunch of representatives, you'd have to deal with a lot of annoying nonsense, and maybe a few weeks later, if you're lucky in the mail, you may get a data sheet, may not. Now it's just Google. So it's right over here. It says, apply 2 volts or more for normal operation. And if there is nothing there, it's simply going to shut down. So let's take another look at our schematic over here. Now, this is going to be either 8 volts or 18 volts, right? And there's a resistor going from here to here. Otherwise, this is simply not going to work. There's going to be 0 volts there. So if this resistor is blown, if R7080 is blown, do you think I'm going to have 3.42 volts? No, I'm not. I'm not going to have any voltage, and it's not going to work. But if I replace that resistor, then we get something that looks like this. The new Airs do this stupid crap where it turns on, then off, then on, then off, then on, then off, then on, after you take the battery out or something, and then plug it back in. But come on, boot, don't make me look like an idiot. Yeah, I don't need you stalking my customers, but needless to say, we're good. One of the things I want to get across here is knowing how to go down the right rabbit hole. So the problem here, again, I had 0.5 volts on PP-Bush D3 hot. Now, what a newbie is going to do is look at the schematic and see that that was the first voltage listed on that page, and they're going to go, oh, I need PP-Bush D3 hot to be 8 volts. And they're going to start trying to figure out why PP-Bush D3 hot doesn't work. They're going to look at that circuit, so they're going to look at what creates it. If they're smart, they're probably going to go to U7100, and they're going to search this area, and they're going to measure. And just look at how much stuff there is to measure in this area. Like, look at all the crap that they're going to wind up measuring to try to see why PP-Bush D3 hot isn't working. And this is what's called, again, this is going to become a rabbit hole to hell for this person, because this entire circuit works. So, I know that I need 3.42 volts for the one-wire circuit. I know that I need the one-wire circuit to turn on the charger. I know that without the one-wire circuit working, that this chip over here is never, ever, ever going to do its job. I know that. I know that the one-wire circuit communicates with the SMC. I know that the SMC communicates with this chip. And I know that because in previous schematics, this was made just a little bit simpler. So if I were to go to an older board over here like this one, I'm going to show you how I first figured out how this worked. Because again, I didn't know what one-wire protection worked. I didn't know what power supply turned on worked at first. I didn't know that one thing turns on the other. A lot of people just kind of think I'm born with this information, and I'm really not. It's not like I went to a school where they just explain this to you. So one time I just said, you know what? There's no power. Let me look by the MagSafe DC power jack. And what I noticed is right by the MagSafe DC power jack, there's this little line called adapter sense that talks to this chip. And this chip is powered from this one based on this little logic gate over here. This little logic gate comes from the power supply for PP-Bush D3 hot. If the PP-Bush D3 hot power supply doesn't work, it's never going to allow this signal to be high, which will never turn this on. See where it says VCC over here? That means that's power input for a chip. So like here they call it VN, here they call it VCC. Who really gives a fuck? I'm telling you that's what it is, and just believe me. And so that's going to send 3.42 volts to here for this to work. So this has what's called a bidirectional data line with cis1 wire. So that data line is actually created. See this little resistor over here? That's a pull-up resistor. So that pull-up resistor is going to allow a data line between the external source of adapter sense coming from your adapter and the internal source, which is cis1 wire, which communicates with the SMC, U4900, the System Management Controller. So I would just think to myself, why is it that the SMC wants to talk to the charger? Oh, that's a system management controller. Oh, that controls charging and looking at the battery and things in the system. Oh, maybe it wants to talk to the adapter to tell it to turn on. And that's when I figured out that let's say if this has water on it and this little line is missing, this PP3V42 is missing, that this logic gate is not going to work, which is not going to send power through over here, which is not going to allow this little pull-up resistor to create the data line where this over here, adapter sense, can talk to the SMC, and it's not going to work. On this newer system, it's a little bit more difficult because you don't really have that direct connection. Because again, I can read this till I'm blue in the face unless it's right next to one another and I have a reason to think that something is true. I'm not going to just jump to that conclusion. Is all that information in the schematic? Yes, but it's not there annotated. It's not there in a manner where I can really read it and gain a good understanding of it. So when I'm on this part of the schematic, here's one of the things that I want you to be thinking. Here's kind of the mindset that I want to be teaching you to be in. So again, what I said here is that it's really important that you know that you needed to look for PP3V42 missing, not that PP-G3 hot is missing, and that you need to know the order of it. Because again, when you go to that page 61 on this sheet, when you go to page 61 or 63 or whatever it was, it doesn't give you the order that these power supplies need to be on the board. It doesn't. We start with PP-G3 hot. 1, 2, 3. PP3V42 is 5 in. If this made any goddamn sense, this thing over here would be on the top. This would be listed. This would be listed in the chronological order that the power supplies need to show up. So PP-G3 hot is missing, and PP3V42 are also missing. But you need one to create the other. You should be looking for the one that's missing that you need first. But how do you know which one is missing that's needed first? You need to use your brain and look on the schematic, because Apple are too many... for the lack of a better way to say it, they're just fucktards that don't want to tell you. If this document made any goddamn sense, PP3V42_G3 hot would be at the top because you need that power rail before you get PP-G3 hot. PP-G3 hot is listed first, even though that's a power rail that's going to show up second, because the people making this document, they're not making this document for you. That's one of the things you need to understand when you're looking at these documents. These documents are made by somebody who simply, they just need to get it done because that's their, $40,000 or $50,000 a year job to do, is to sit here and print out documentation for things that the engineers tell them. They're not, that's really that. So it's, okay, so what power rails are in the machine? Okay, these are it. Let's just list them. It's not really about making it easier for you to troubleshoot it, because when it comes down to their job, they're never going to be troubleshooting this, so it doesn't really make sense for them to come up with a practical way to explain it to you. But the way that you explain it to yourself practically, and the way that you figure this out, and the way I want you to be thinking so that you can figure this out on your own in 5 or 10 minutes, is look over here. So PP-DCN_G3 hot, that is coming in over here. That is the charger. The charger is where all of this stuff begins, right? This is where it begins. Now, right after the charger, the first thing you see is not the line to PP-G3 hot, is not the line to a 5-volt supply, is not the line to any other supply. The first thing that you see after the charger is PP3V42. So what this should do in your head, what this should do is tell you that this is probably the one that I should look at first. So if I'm missing PP3V42 and I'm missing PP-G3 hot, the first line that you should look at is PP3V42, because it's the one that's right after the charger. And then you'll be chasing the right rabbit hole. Again, if I have a choice between spending my time measuring all the resistors in this circuit, and then I have a choice between measuring all the resistors in this circuit, I'm going to waste a lot of time if I measure everything in this circuit, because that doesn't have to turn on first. And not only would that doesn't have to turn on first, but every single thing in that circuit was obviously fine. So again, the document is not going to make it easier for you. They're not going to tell you the order in which things are supposed to happen. You're really going to have to figure that out on your own, because these documents, they're just made as just a bare minimum documentation to say, this is what's on this board, this is what's in the circuit. This is not a service manual. This is not there to make your life easier. But if you learn how to decipher the content that's there, it will start to make your life easier.